Now, sometimes we want to use a different data type in our database from the one that we're using in our model, and that is where value converters come into play. Now, you might be saying, Hannes, we saved that release date as a date in the database and not as a date time. Isn't that a value conversion then? Well, no, because for Entity Framework, both of those are date time fields, and it's not really converting anything. Now, if we want to save this as a string, however, that's a different story. Then we are going to need a value converter. So let's take a look at our mapping. And if I were to redefine this field as a car23, for instance, and the reason I'm saying 23 is because I know that a date time to the milliseconds fits in 23 characters. So now I have a string in the database and I have a date time in my model, and I'm going to need a value converter. And I can do that with hasConversion, and I can just pass in the generic type parameter string to convert it to a string in our database. Now, in its simplest form, this is a value converter, and that should be enough. So if I now run this code, we can take a look in our database what we are getting. And remember, we do have that seed method that adds a movie to our database. So let's take a look in our Azure Data Studio to see what we've got. And as you can see, we now have a pictures table, and that has a release date that is a car23. And if I now query this data, let's take a look at what we have there. Yes, indeed, it is filled out as a proper string. So this value converter did its work. Now you could wonder, why is it working so easily? Why didn't we have to write more code? And that has everything to do with the built-in value converters that Entity Framework has. There are a whole bunch of predefined conversions that we can find inside Entity Framework. We can convert between bool and numeric types or strings, between enumerations and strings and numerics. We can also do conversions between datetimes and longs or datetimes and strings. So this is the one that we actually use. And that is because a whole bunch of predefined value converters are shipped with the framework. And this is the list here, the built-in converters. So the thing that we are using is actually the datetime to string converter, this one. Now, we can either use all of the built-in ones, or we could write our own. So let's say that we want to make this a little bit more efficient and we want to save this in a car8. Now that becomes a whole different story. Let's say that we just want to have the date as a string, but without any dashes. Well, that is a scenario that is not supported by the built-in converter, so we're gonna have to make our own. So let me quickly make a folder for our value converters. And when I have that, I'm going to make my own value converter. And I'm going to call it datetime to char8 converter. Now, when I make this one, I'm going to have to do it by inheriting from an Entity Framework core base class, namely value converter. And that one takes two generic type parameters. The first is for the data type on the code side, on the model side, and the second is for the data type on the database side. So if I have to implement this one, I'm gonna have to have a constructor. And the easiest way to make this happen is just make a constructor that calls the base constructor. Now, the base constructor in this case takes two parameters, and those two parameters are the ones that convert from a datetime to a string and to a string to a datetime. You basically pass in two functions. So the way that I usually do this is the first one is to convert from a datetime to a string. So all I'm going to have to do is make a lambda that does just that. Now I can put this into separate functions to make this class more clean, but this just requires two one-liners, so that's going to be more than enough. In this case, I can do datetime.toString, and the string parameter that I'm going to have to pass in is year, month, date. And I'm going to do this with culture info invariant culture. Now, the second parameter is to convert in the other way. So I could do string value, and I'm going to convert that to a datetime again. So I'm going to do datetime.parseExact. I'm going to pass in the same string and the same culture info. There we go. So those are our two conversion methods. Now to do this, of course, I have to pass in the string value that I'm getting from my lambda. Now this should be sufficient. This should be a working value converter. Now to use this in my mapping, what I have to do is say hasConversion, and instead of passing a generic type parameter, what I'm going to do is I'm going to say new datetime2. And then we can basically use our car8 converter, and that is how you map a custom converter. So let's rerun our application and let's see what we have got in our Azure Data Studio. So now this runs and this code should be just fine. And I'm going to go into Data Studio and let's refresh this table and let's see what we've got. And indeed, we've got a char8 column. We can also requery the data, and what we're seeing here is indeed a 1999-0910, what we expected. If I now query this API, I can basically get our movie back as well, and that should have the correct data in it once more. So let's execute this, and indeed our Fight Club has the properly converted datetime field in it. So that's how you do your own value conversions. Now there is one more thing that I want to cover when we're talking about value conversions, because there is a very big pitfall. Now let's say that in our movie we also want to keep track of the age rating. And because age rating might have only a certain number of different values, we're not just going to make it a number, we're probably going to model that as an enumeration. So I have already prepared a small enumeration for this. Let's say that our age rating looks like this, and we have movies that are suitable for all ages: elementary school children, high school children, adolescents, and adults. Now 0, 6, 12, 16, 18, that kind of matches what we see in movie ratings as well. So let's say that we want to add a property here for our age rating. So I'm going to do just that. Now our movie has an age rating, and if I do nothing, then Entity Framework is going to save this into the database as an integer. And that will work just fine. Now to play with this, I'm going to add a new controller method as well. So I'm going to take this controller method, and that controller method will allow me to get all the movies until a certain age. And that accepts an age rating. And what this does is a simple where clause where age rating is smaller or equal than the age rating we're getting from our route. Nothing fancy, you've seen code like this before. Now, if I want to make this work with strings in our JSON, then it would be nice to have a JSON string converter. This has nothing to do with Entity Framework, but if you want to make it work cleanly in the UI as well, you're going to have to do a little bit of work. We're going to have to add some JSON options to make sure that it works with strings in our UI. So on the add controllers, I can just add JSON options, and this is exactly what I wanted to see. Now the string enum converter is built into system text JSON, and if I do that, all of my enums will be treated as nice string literals in my Swagger UI as well. So before I run this, I'm gonna have to do one last thing, and that's make sure that our Fight Club movie has an age rating. So let's take a look at the movie mapping and let's add an age rating for our movie. And Fight Club is a pretty violent movie, so let's say that we're gonna need age rating.adolescent. Now, first of all, let's run the application and see what happens. Our controller method should allow me to fetch that movie depending on what parameter I pass into it. So I have my movies until age rating, and because I added those JSON properties, I cannot say that I want movies that are suitable for all ages, and I'm not getting Fight Club. Of course, if I query movies from adolescent, I should be seeing my movie, and that works perfectly fine. Now in our database, this is now saved as an integer. So let's take a look, and we see our age rating column as an integer. Now the risk lies when we try to save this as a string, and this is a very typical pitfall with enumerations as strings. So when we take the enumeration in our model and we save that in the database as a string, we have all done this before, so let's quickly add that. We do age rating, and we say has column type, and that column type is going to be a varchar32, and then I'm going to say has conversion string. Now that should save our enumeration into our database as a string. And if I rerun the application, that works perfectly fine. We will see our Fight Club in the database and the string should say adolescent. So let's first hop into Azure's Data Studio and check that. Now our age rating is a varchar32. And if I select the data, we should be seeing that indeed as adolescent. So when I go back to my Swagger UI, and this is where it will go wrong, if I query this for adolescent, we will get our Fight Club movie. And that works just fine. But when I query this for high school, where I should not be getting Fight Club, when we query this, I still get Fight Club. What's going on? Let's take a look at the query in our logs. And what we see here is that Entity Framework is doing a string-wise comparison and not a number-wise comparison. So while in code, this statement in our controller makes sense because in code, this would be a comparison on the enumeration, this gets translated into a query in the database, and then it is doing a string-wise comparison, and because high school is string-wise higher than adolescent, it is giving back our movie. It gets even worse because even for all, which would be for elementary school and kindergarten children, I'm still getting my Fight Club movie because string-wise, all is bigger than adolescent. So this is something you really should be paying attention for as soon as you start mapping strings to enumerations, because you will get a different behavior in the database from the one that you expect to see in code. And that's all I wanted to say about value converters.